Hey guys, welcome back to my YouTube channel. Today I'll be teaching you guys how to draw Lewis diagrams with more than one central atom, right? So a central atom is essentially the atom that's kind of in the middle of it all, right? So for example, if we do methane, carbon will be the central atom because it's kind of in the center, as you guys can probably see. Okay, but Lewis dot diagrams with more than one central atom, here's how we do it. So usually you're going to see like a Lewis diagram with carbon, right, with more than one such atom, because carbon tends to form like a lot of bonds, right? So let's first determine which of these two elements are able to form central bonds, right? So we all know hydrogen cannot form a central bond because hydrogen is not diatomic. No, I mean hydrogen is diatomic, but it can't form double and triple bonds. Also, halogens cannot form double or triple bonds, right? So we all know hydrogen and fluorine cannot be the central atom, thus leaving us carbon and nitrogen. So let's just throw those in the center. Now, the placement of where the next elements is going to be really similar to what's shown on the element, on the thing, on the sentence, right? So we have hydrogen, which is right next to carbon, and fluorine, which is right next to nitrogen. So if you put it over here, hydrogen, and hydrogen, right? And another key thing to look out for is also of symmetry, right? So if we put fluorine like over here, that's fine, but it doesn't look really symmetrical, right? So let's just put fluorine for the sake of it over here. And you guys are going to see why. Because if we fill in the other electron things, right? We're going to double bond carbon. So that way it evens out. Look, there's a lone pair in the central atom, which also lines up with this and this. And this lines up with this and this. So that way it's symmetrical. And here's the answer for reference. Next one, we have C2, H4, and Br2. Carbon, when it's calling for central atoms, is most likely going to become the central atom, right? So we already know that's a given. C and C. Okay? Hydrogen is also Hydrogen is also close to carbon, but we also have bromine over here as well. Okay? So for that, let's do hydrogen, one over here, and then a hydrogen over here, and over here, just to balance it out for symmetry. And for bromine, we're going to put it on the bottom, like this, right? The reason why we don't put one bromine over here and then one bromine over here is because we want to try to make the molecule as polar as possible, right? So that way we know these are two dipoles. Okay? If you guys don't know what that is, please watch my video on electronegativity and finding the molecule on bond polarity, right? So anyways, we have bromine over here, and if we bend this out over here, we have a pretty cool molecule that has two central atoms. And here's the answer for reference. Oops, I must have done that wrong. Yeah, I did that one wrong. So just ignore this answer. Finally, we have CH3OH. Let's first determine, because there is no two carbons, let's first determine which atoms can make the central atoms, which element can become a central atom. So hydrogen cannot become a central atom, okay, because it cannot form double and triple bonds. Therefore, we have carbon and oxygen able to become central atoms. Carbon and oxygen. Now, this is a more trickier one, okay, because how can we put these things into symmetry? So instead of putting it here and here, let's put it diagonal, because we can still do that. Let's put one over here, one over here, one over here, and one over here. One, two, three, four. Okay. Or we could put it like this. Let me show you. CO, 1, 2, 3. Like this, because these are still evened out. Look, we have two symmetrical, and two symmetrical. And here's the answer. Thank you guys so much for watching this video. To be honest, I'm still a bit confused on this topic by myself. So I'm going to work on this more, and then I'll come back with a better solution. Bye, guys.